That's right. This total distance, C. That means this little distance will be C minus D prime. From this equation, the only unknown epsilon steel prime, compressive strain in steel. This value must be, to make this condition correct, must be equal or greater than or equal epsilon yield, yielding strain. If this happens, your assumption is correct, your calculation is correct, you are done with your design. If this one not correct, smaller than epsilon yield, no. Everything is incorrect because your compression steel did not yield. We need to do another calculation. We will discuss it right now. Maybe today or next time. Just what I did here. We need to check if the compression steel yields or not. First, locate the neutral axis. What is the value of C? After you calculated A, we can figure out what is the value of C. Make triangle similarity. What I did here, between this triangle, the biggest one, this distance is C, not X, and the little one, this one. You can get what is the value of strain in steel reinforcement in compression. So epsilon steel prime, compressive, strain in steel in compression. If this value greater than or equal yielding strain, and yielding strain equal F yield over ES, then compression steel reinforcement has yielded and you are done. The previous calculations are correct. But if epsilon steel prime smaller than epsilon yield, then compression steel reinforcement did not or hasn't yielded, then repeat your calculation as follows. Let's do first this example and see what will happen. We have area steel prime equal 2 inches square, 2 number 9 bars. Number 9 bars, cross section area equal 1. We have 2 bars, so your area 2. Down, we have 4 bars, number 11. Your area steel equal 6.25. This distance called D prime, 2.5 inch. This total distance called D equal what? 21?
24.
No, not 21. 24.
24.
21 only from this point to this point. But your depth for steel reinforcement in bottom from the top of the cross section. Anyway, so we can figure out what is the value of area steel prime, what is the value of B, what is the value of D prime. Assume compression steel yields. So I would like to solve my problem like this. We have neutral axis. I'm not sure where, but this neutral axis at depth C. We have something called strain distribution. Compression, tension, and at this location 0. So we have epsilon steel in tension, we have epsilon concrete, C ultimate equal 0.003 according to ACI. At this location, we have epsilon steel prime. Also, we have something called stress distribution. For concrete in compression, we have stress block a little bit before your neutral axis with depth equal E. Your stress 0.85 F prime C. Do you agree? We have compressive force C. C. We have another compressive force called CS. One in concrete, one in steel reinforcement in compression. And we have tension force in steel reinforcement below the neutral axis. For equilibrium, if you apply summation f of x equals 0, CC plus CS equal T. CC 0.85 F prime C A B plus CS we assumed yielding. So area steel prime times F yield equal T area steel times F yield. Go ahead and put your numbers. 0.85 F prime C 3 times A times B. What is the B? 14 inch plus area steel prime 2 inch square. F yield 60 equal area steel 6.25 times 60. The only unknown in this equation, your distance A. So 4.25 times 60 divide 0.85 times 3 times 14, 7.14 inch. By chance, your A equal beta 1 C, A 7.14, beta 1.85. Why? Because your concrete compressive strength equal or smaller than 4,000. So your beta 1.85. So I can figure out what is the value of C. 8.4 inch. Any question so far? Any question so far? This cross section can be divided to two parts. First part, your area steel prime and area steel 2. Area steel prime is 2 inch square. Area steel 2 will be 2 inch square. This cross section plus another part with area steel 1 with concrete. Remember, at the bottom, we need the total area steel to be 6.25. We take 2 of them, 2 inch square from them, the remaining area steel 1 will be 4.25. So, from the first part, nominal moment equal this area steel time F yield time depth minus A divided 2. Second nominal moment, one of them, area steel, time F yield, time D minus D power. First one, your compression here and your tension here, the distance in between D minus A divided 2. Your compression here and your tension here, the distance in between D minus D prime. This is the meaning. So what's this value? What's this value? Remember, your depth, 24. Your A as a distance, 7.14. Your depth, 24. Your D prime, 2.5 inch.
I got 5,209.65.
5,209
0.65.
Kib inch. Your F yield KSI. KSI means kib and inch. Your area in inch, every distance in inch. So your final value as a moment, kib inch. What's the second one? 2,400.
580.
508.
80.
Kib inch.
Dr. Arena,
Yeah.
where did the 4.25 come from?
I'm sorry.
On
D total depth.
the 4.25. Yes.
Go back to this one. We have steel reinforcement in compression equal to.
Okay.
We have area steel in tension equal 6.25.
Okay.
We have cross section. This cross section can be divided into two parts.
Right.
The first part consists of area steel in compression and the part of the area steel in tension equal to area steel in compression. So this one was 2, this one will be 2. And the second part, your cross section of concrete plus remaining steel. The total steel area 6.25. We told 2 to be equal area steel prime, so the remaining one will be 4.25.
Okay.
So the total here is 6.25. The total is here is 2. This is the two parts. Okay. So keep going. What is the final nominal moment? 5,209 plus 2,580. You can get your final answer. What is the design? Phi MN 0.9 times your final answer. You can get your design moment. Remember, it's in kib inch. You can divide it by 12 to convert it kib feet. That's right. Are you done? Not yet. You assumed assumption at the beginning. We need to be sure this assumption is correct or not correct. At the beginning, you assume compression steel yields. Your assumption is correct or not correct. Let's see. Finish first your answer. Your check if compression steel yields or not. How can I check? Go back to your strain distribution between this big triangle and this little one. So 0.003, this value divided by this value in the second triangle, epsilon steel prime equal. This distance in the first triangle, which equals C, which equal 8.4, divided by this little distance in the second triangle, which equal C minus this little distance D prime. C minus D prime. D dash. The only unknown in this equation, epsilon steel prime equal uh, 8.4 minus 2.5 times 0.003 divide 8.4, your number 0.0021. What is the value of epsilon yield? Equal F yield divide E steel. Yielding stress 60, E for steel 29,000. You need to keep this round number in your mind. E for steel 29,000 KSI. Can you divide 60 by 29,000? Your value will be 0.00206. I think epsilon steel prime compressive strain in reinforcement equal 0.0021 is greater than epsilon yield or equal. That means your assumption is correct. Yielding happen in reinforcement in compression. That means here is your final answer. I am done. This is the steps to design reinforced concrete cross section with double reinforcement. One in tension and one in compression if your steel reinforcement in compression yields. Any questions so far?
Could you explain that last part about what we just found, epsilon yield and epsilon steel significance?